We're at go-to-math.com. Let's click on the calculus, go down to definite integrals by definition, and we're going to be looking at this one here, so we'll just click on that. Now, 1-1 was kind of long, and the reason for it is I went into some explanations. I'm not going to go into all those explanations. We're just going to kind of work this out. All right, show you the steps on how to do that. So you want to probably click on this one here if you want to see some further explanations on that. But let's go back, and I'm trying to find some nice numbers here. That looks good, kinda. Not really. That's good. Okay, so let's write this down. Alright, we got that written down. Let's move over to the whiteboard and let's see what's going on over here. So we have the integral of going from 3 to 6, 5x squared dx. Now I do have a section where you would realistically, I believe it's called Simpson's rule, and there's another rule, can't think of it for some reason, my brain's whacked out today. Anyway, for approximating these integrals, you want to check this out. Alright, this is just kind of doing it generally, which I'm not sure it's practical in the real world, because we're going to come up on something here in just a minute that something you got to remember. Of course, you got to remember everything, I guess, but yeah. Now we're doing right endpoint. Right endpoint, what exactly does that mean? Right endpoint, if our curve is looking like this, let's say, and we can think of this as finding the area under this curve, okay? And right endpoint means that we're using the right endpoint of the box. If you notice, this box right here intersects, its corner intersects the curve, and then of course we have another box, okay? And we're adding up all these boxes in some interval here. But the whole idea is this thing going to infinity means there's going to be an infinite number of boxes. In other words, we're going to make these boxes really, really tiny, small, to get a better approximation. Actually, it's going to be an exact of the area under the curve. I mean, it's an amazing thing if you think about it. Anyway, right endpoint means you see the right parts up here, the top right corner. Okay, that's what we're using when we go to find delta x, or our CI, I mean. So delta x, remember, is if this is a and this is b, it's b minus a. So this is going to be 6 minus 3, right? And then over n. Okay, so that's going to end up being 3 over n. Wasn't that our last problem? No, it was 6 over n. Never mind. Anyway, so we got 3 over n. We figured out what our delta x is. Our CI is, we'll start with a here. So that's going to be 3 plus, and then our delta x, which is 3 over n, times our I. Now in problem number 1, you want to see that because I go into the more details on all that stuff, but that's how we figure out what CI is. And then we plug CI into the function. Now remember, the function f of x, we're going to go ahead and write that out here, is 5x squared, okay? And so I'm just going to go ahead and write this part right over here. So we end up with the summation of I equals 1 to n, okay, f of CI. So CI is this right here. We're going to plug that in to our x here. So we end up with 5 times 3 plus 3 over ni, okay? And of course that's all squared, and then our delta x is 3 over n. delta x is 3 over n. And so now what we want to do is go ahead and compute this. Now that all that's said, let's go ahead, take this 5, let's take this 3 over n, and let's take it outside the summation sign here. So that's going to end up with 3 times 5 is 15 over n, and just get that out of the way. Now I said there was something that you were going to have to definitely remember, and that is, what is this? The summation I going from 1 to n of I squared, right? That's obviously something you'll have to remember, because that's what we're coming up with right here. That's what we're going to be coming up against here in just a minute. All right. Okay, so now we are at 3 plus 3 over ni, and this is all squared. Now, what we'll want to do here is go ahead, let me write an equal sign because it's still equal to this up here. Let's go ahead and FOIL this thing out, right? We're going to square it out, so we're going to do a little side work here. And we got 3 plus 3 over ni times 3 plus 3 over ni. Alright, and let's go ahead and multiply that out as much as we don't want to. I keep forgetting about something here. Get switched over to that screen. So we have 3 times 3 is 9, right? 3 times 3 ni, so that's going to be 3 times 3 is 9. Ni plus, and then we got 3 over n times I times 3, which is 9 over ni. And then we're going to be multiplying, let's see, these two guys together, so that's going to be a 9n squared times I squared. So there's your I squared that you're going to have to come up with. Alright, we got to remember what that is. Okay, so now what we can do, let's go ahead and just here we'll do a little side work. Let's just do it down here. Let's go ahead and simplify this down a little more. So we have 9 plus, and so we have 9ni, so that's 2 of them, right? 2. And so that just becomes 18 ni, okay, plus 9 n squared I squared. I got a comment on a video and differentiation or something, and some guy was like, you didn't finish the problem or something of that nature. You didn't show how to factor. Well, you know, the reason is, first off, I was using a video capture that only allowed me 5 minutes, and so I didn't have a whole lot of time, so I had to cut out, you know, some of the real basic steps. And you know, I mean, the videos are an hour long if I actually put in every single step. Anyway, what we're going to do now is I'm going to go ahead and break this up into 3 different summation problems. All right. And so I'm going to go ahead and do 15 over n here. Put a bracket, okay? Break this up into 3 separate ones. And I think on the next video, I'm probably not going to do that. On problem number 3, I'm not going to break this up, because, like I said, it's just a whole lot longer. It adds a lot more length to the video, and people like zone out after. Hey, I'm going to go ahead and take this 18 over n out front. People tend to zone out after 5 minutes, and that's kind of the magic number when it comes to making YouTube videos. Is 5 minutes. That's average time people watch, and it's like if they don't learn it in 5 minutes, they move on to feeding the dog, watering the plants, or probably heading down to the nearest brew pub and getting a beer, saying, I'm telling their friends, you know what, I'm getting the hell out of this class. W is looking pretty obvious now. Anyway, hopefully not. Okay, so we broke this up into three separate ones. Now let's go ahead and do each one of these. So we've got what is this? Actually, you know what? Let's not skip any steps. I don't want to get any complaints. Um, okay, so this just becomes 9n, right? Yeah, I wanted to say 9i for some reason. Plus, now we did this one in the previous video. The summation of this guy right here is going to be n times n plus 1 over 2. So this is the summation. That's what this guy is equal to here. And now we've got one that we may have not ever seen before. I don't know. And that's going to be this guy right here. What is this summation equal to? Well, it's similar to this one, except a couple things have been added to it. We've got n times n plus 1, all right? And then we've got 2n plus 1. Now, this is not really the class where we actually derive this. It's more of a discrete math class. Maybe when I have discrete up someday, I'll show you how to do that and then use mathematical induction to show that that is it. All right. Well, there it is, and yeah, this looks pretty nasty to me, but we're going to try to do something here. I don't know. We need to get all this into one single fraction so we can actually take the limit. Now here's some things we can do. We know that those cancel out. Okay, that's good. We know that 1n is going to cancel out here and we're going to be left with just 1. So let me just scratch that out. Okay. What else can we do here? 2 goes into 18 9 times. I'm going to cross that out, put a 9 there. All right. And then we can simplify this down. 3 goes into 6 2 times. 3 goes into 9 3 times. All right. And let's go ahead now and just kind of rewrite this. So we have 15 over 9, 15 over n, not 9. 9 does start with the letter n, but anyway. Okay, so what did we do? We crossed out, so we have 9 times n plus 1 plus, cross out n's, we're left with 1 n down here. Wow, that's terrible. We're left with an n down here. Down here in the bottom, 3 in the top. So 3 n plus 1 times 2n plus 1, and that's all over 2n. Okay, so this is where we are so far. Man, and we're at 13 minutes. Let's go ahead and punt. Now, let's, what do we want to do here? On a zoom, and a zoom. All right, let's see. Let's just go ahead and do this. So we have 9n plus 9n plus 9 plus, and God, we got to multiply all this stuff out. You know what? I'm going to pause the video, do that. Hopefully you know how to do that. It's n times n times 1, 1 times 2n, 1 times. You know, let's pause the video. Let's work on this stuff. Okay. We try to cut some time down here a little bit. Anyway, if you multiply this stuff out here on top, you should have 6n squared plus 9n plus 3. Okay. And then this is going to all be over 2n. All right. And so what's going to happen here is we got 9n, that's 18n. Then we got plus 9. All right. And like I said, I'm going to do some serious skipping here. Sorry for all those people that need every step, or this is going to turn into an hour video. All right. Anyway, you should be able to go from here to hopefully, let's go from here to 42, and after doing 42n squared plus 27n and then plus 3 plus 3, yes, do plus 3 there, and then that's going to end up being all over 2n. Alright, so then what's going to happen, you multiply that 15 across inside. Okay, multiply the 15 across, we should end up with 630 n squared plus 405 n plus 45, and that's going to end up being all over 315. Now, the next order of business is you want to take the limit of this thing as n goes to infinity, and what the heck? Sorry about that. That should be 2n squared down here. I was definitely getting ahead of myself. So we take the limit of this as n goes to infinity. You notice that both our leading terms here have the same power. Alright, so then you just take their coefficients. It just ends up becoming 630 over 2, and 630 over 2 ends up being 315. Alright, ends up becoming 315. And so the limit as n goes to infinity of all that stuff ends up becoming 315. Alright, trying to save a little time here. Hopefully you got it. Okay. I hate to have to do that kind of stuff to you. I know I'll end up getting complaints as usual. The limit as n goes to infinity, yeah, I'm going to go ahead and write it out. 630 n squared plus, you hope you just have one of these on your test, but you know it's going to be on the test. You know it's coming, right? I mean, guaranteed. And it should be, because this is like really the foundation of the integral part of calculus here. Okay, so this ends up being equal to 315 when the smoke clears. Should I write that right here, 315? How about I write it right there? So really the magic thing is you got to remember what this was equal to, n times n plus 1 times, if I can squeeze this in here, what was that, 2n plus 1? Is that what it was? 2n plus 1 then divided by 6. And in the real world we'd use an approximation method, and I used 2 of them. Anyway, so we had to remember what I squared was, and then also I, the summation of I. Okay, but in the real world, let's find it. Numerical integration, right? Numerical integration, and of course I do that. A couple of these problems here. We use the trapezoid rule. That's what I was trying to remember. And then there's the Simpson's rule. I don't even know why I even went here. Got off tangent. Simpson's rule, right, for approximating. And actually, it's a really good approximation. Simpson's rule is for doing this. But we got to drag you through the mud first, all right? Because it's just all rite of passage, man. When we're studying calculus, got to weed them out. Anyway, there it is. You know where to go. Go somewhere. Go right here. Go to home. Go to math.com. Check it out.